This section has two theorems. One's called the remainder theorem, and all it says is if you take a polynomial and divide it by this guy, that's a linear binomial, then the remainder, r, the very last number, is the same as if you were to plug k into your function. So here's an example. I've got x minus 3, and I'm dividing it into that. That's nice since it is linear, right? This is linear with a equals 3. I can use synthetic division. So 3 on the outside. Are there any missing powers? No, I've got 2, 1, none. So my coefficients are 1, negative 2, negative 8. Okay, the process says bring the first one down, multiply diagonally, write it above, and then add those numbers together. Repeat for that one, and you get negative 5. This is the remainder. Now this theorem says if I now evaluate, that just means plug in, x equals 3 into my function, so essentially I'm finding f of 3, which means everywhere there's an x, I'm going to plug in a 3. We've got 9 minus 6 minus 8. That's 3 minus 8 equals negative 5. So notice that f of 3 was negative 5. That 3 was the same thing as this guy. And my remainder was my answer. So this theorem can help you when you're trying to evaluate. Now this was a simple one to plug in and evaluate, but imagine if it was huge, right? Or it had really high powers and the number was 14 or something. So the basic thing is to evaluate a function at x equals k, use synthetic division, and the remainder is your answer. This will be your a. This is your outside number. Okay, here's some examples. Use synthetic division and remainder theorem to evaluate for the given x value. Again, you could plug these in pretty easy. This right here says that a is 5. All right, 5 on the outside. Our numbers for our coefficients, nobody's missing. Squared, x, constant. Okay, the process says bring down the first one. 5 times 4 is 20, write that above. Add down. 5 times 10 is 50. Add down. 29. So this guy right here, that's our remainder, which means f of 5 equals 29. That's what the remainder theorem does for us. All right, this one right here, it says to evaluate, use synthetic division when x is this value. So notice in the synthetic division problems that we were doing before, we had to do the opposite. This one is not the opposite. Not the opposite. The ones we were dividing by before were just x minus or x plus a number. There was no equal sign involved. With the equal sign, you do not have to do the opposite. So right here, it is not the opposite. Okay, back to here. So negative 4 goes on the outside. Coefficients inside are 5. Negative 1, nobody's missing, so 13, 29. Regular old process, bring down the first one, multiply diagonally, add down. Multiply diagonally, add down, multiply diagonally. That's negative 388. Okay, adding that would be negative 359. Okay, this right here, negative 359. That means that's the remainder. which means f of negative 4, it's not the opposite, is negative 359. Okay, the next theorem is the factor theorem. Now this one's going to be very useful when we start finding zeros and we factor stuff. It says a polynomial has a factor, x minus k, if and only if f of k equals 0. So this right here applies the remainder theorem. It's saying if f of k equals 0, then there is no remainder. So show that the binomial is a factor of the polynomial. What we're looking for is the remainder equal to 0. Right? This is using the previous one, f of k. If we are, the remainder theorem says if you divide by this and you get, then the remainder is your f of k. So we're going to use synthetic division to show that it is a factor. So is there an equal sign? No equal sign. So we've got to change to the opposite number. There is no equals. So we need the opposite. So our a is going to be negative 2. Okay, that's the number on the outside. Inside coefficients, look for missing terms, x cubed, x squared, x, and 8. We're good there. 1, 2, negative 4, negative 8. All right, usual steps, bring down the first one, multiply, add down, multiply, add down, multiply, add down. Here's the remainder. If it is 0, then you would say yes, it is a factor. All right, use synthetic division to determine whether the given binomial is a factor of the function. So we are going to take x minus 2 and divide it into this polynomial right there. Okay, there's no equal sign, so we need the opposite. That means a is 2. So 2 on the outside. Looking at our powers, 3, 2, 1, none, so we're okay there. Coefficients, 1, 1, negative 4, negative 4. Bring down the first term, multiply, multiply and add, multiply and add. Bam. Remainder is 0. Yes, it is a factor. All right, let's try this one over here. Let's see, no equal sign, so a is going to be the opposite. Negative 3 out front. We are missing x squared, so we're going to do plus 0x squared in here, which means my coefficients are 1, 0, negative 5, negative 3. Number one error with these guys is forgetting to put that 0 in that spot. Right, same process. Bring down the first one, multiply diagonal, right above, and add. Multiply diagonal, right above, and add. Multiply diagonal, right above, and add. Okay, this is the remainder. It is not equal to 0, so you would say no, it is not a factor. Okay. This one says show that x plus 3 is a factor of that. Okay, we know how to do that. Synthetic division, remainder must be 0. But then it also says to find the remaining factors. So let's start with just finding showing that it is a factor. So a equals -3. We've got a missing term here. So my coefficients are 1, 0, -19, -30. Okay, process says take down the first term, multiply diagonally, add down. Multiply diagonally, add down. Multiply diagonally, add down. Yes. Remainder equals 0. Yes, it is a factor. Okay, second part then says to find the remaining factors. So what a factor means is that it is something that divides evenly. Obviously, that's why the remainder is 0. But it also means that this trinomial right here can be rewritten as some factors where one of those factors was x plus 3. That is what the factor theorem says, is if you can find a remainder that's 0, then this guy is one of the numbers inside, or sorry, is one of those pieces inside there. Okay, I need to make more room. So, x cubed minus 19x minus 30 equals, for sure, one of our factors, that's what this proved, is x plus 3. Now to find the other one, it's just a matter of putting your variables back in. So we started x cubed, x squared, x, and then the constant. So we're going to go to here as x squared, x, and the constant. Now we're not writing it out as an answer. We're not going to put the divisor onto the end and blah, blah, at 0, so it doesn't matter. All we got to do is factor this right here. We're going to double bubble it, multiplies to -10, adds to -3, it's -5 and a 2. So this guy right here, just this simple trinomial, x squared minus 3x minus 10, factors into those. Those are our other two factors. So by doing synthetic division, showing that it is a factor, one of the binomials you're given, then all you have to do is look at what's left and say, okay, can I factor that using the methods that I already learned? Okay, that's it. Remainder and factor theorems. They're pretty simple. It's just understanding what they can get used for.